So in this video, we're going to pick up with problem number 19. In problem number 19, we want to solve this equation. 3 raised to the x power minus 4 divided by 2 equals 10. We want to solve for x. So number 19, 3 to the x power minus 4 all over 2 equals 10. We want to solve for x. Notice that x is an exponent, so the significance of this problem is that we're going to have to use logarithms to be able to solve it. But before we do that, we've got to get 3 to the x by itself on one side of the equals. So to do that, we're going to have to multiply both sides by 2. So let's do that first. Multiply both sides by 2. So if we do that, I'm going to have 2 times 3 to the x minus 4 over 2 equals 2 times 10. On the left, the 2's will cancel, and we'll have 3 to the x minus 4 equals 20. Next, I need to get rid of the minus 4, so we can add 4 to both sides. And so we get 3 to the x power equals 24. 20 plus 4 is 24. Now to solve, I need to get that x down from the exponent. And so remember, the trick to that is using logarithms. So I'm going to take the log of both sides. So the log of 3 to the x equals the log of 24. Doing that allows me to pull out the x. So x times the log of 3 is equal to the log of 24. The log of 3 is just a weird number. The log of 24 is just a weird number. So in order to solve, I'm going to divide both sides by this weird number. So x is going to equal the log of 24 divided by the log of 3. So I'm dividing this weird number by that weird number. So if I bring in my calculator, the log of 24 divided by the log of 3 is approximately 2.8928 if I round to 4 decimal places. So this is approximately 2.8928. So if I take 3 and raise it to the 2.8928 power, subtract 4 and divide by 2, that result will be 10. And just for the heck of it, let's verify that. So if I take 3 and raise it to the 2.8928 power, that is about 24. So if I take 24 minus 4, that's about 20. And if I take that and divide by 2, that's about 10. Again, this is approximately the answer that we get. So problem number 20. Let's look at that on a separate sheet. Problem number 20. You are making monthly payments of $300 into an ordinary annuity that pays 9% annual interest. How long will it take to accumulate $10,000? Well, this is an ordinary annuity problem, so we're going to use our ordinary annuity formula. So number 20, our ordinary annuity formula, the future value A is going to equal our monthly payment R times the quantity 1 plus R over M raised to the n power, n the quantity there, minus 1, and that's all over R over M. And so in this particular problem, we're told that we're making monthly payments of $300, so that is R. We know our interest rate's 9%, so that's lowercase r, and we want to accumulate $10,000, so that's A. That's the future value. So again, filling in what I know, we want A to be $10,000. We know that R equals $300 per month. We know that our interest rate is 9%, which is 0.09 as a decimal. And we're making monthly payments, so M equals 12. And so we want to know, how long is it going to take? How long before we get to $10,000? Well, let's just substitute our values in and figure it out. If we want the time in years, then N is going to equal 12 times t, and we'll have to solve and see what t is. If we just want the time in months, then we can just use n without the 12 times t there. Okay, so filling this in, we have $10,000 is going to equal $300 times 1 plus 0.09 divided by 12. That's going to be raised to the, I'm just going to use n here, minus 1, and that's going to be over 0.09 divided by 12. So, if I take 0.09 divided by 12, that is 0.0075. So this right here is 0.0075. So I have 10,000 equals 300 times, so this is 0.0075 plus 1 is going to be 1.0075, and that's raised to the n, minus 1 over, again, 0.09 divided by 12 is 0.0075. And so I'm wanting to find n so that I know how long it's going to take to get this $10,000 accumulated. So how do I go about solving that? Well, I can divide both sides by 300. So if we divide both sides by $300, then 10,000 divided by 300 is going to be 33.3 repeating. So this is 33.333333, and I'm just going to put several threes. I don't want to round too short, or that's going to be a problem. And that's going to equal 1.0075 to the n minus 1 over 0.0075. So next I can multiply this by 0.0075. Really, I'm multiplying both sides by 0.0075. So times 0.0075, 0.0075 times that. So bringing my calculator back in, I'm going to take that 33.33 repeating times 0.0075, and that is 0.25. So I have 0.25 equals 1.0075 to the n minus 1. If I add 1 to both sides, then I get 1.25 equals 1.0075 to the n. And I'm needing to solve for n. So to do that, I'm going to take the log of both sides. So the log of 1.25 is equal to the log of 1.0075 to the n. So I can pull down that n. The log of 1.25 equals n times the log of 1.0075. So n is going to equal the log of 1.25 divided by the log of 1.0075. So if we do that calculation, the log of 1.25 divided by the log of 1.0075, that is 29.86. So that is approximately 29.86. Now that is in, so that would be months. So in other words, it's going to take about 30 months. Now if we want that in years instead of months, we can divide by 12, and so that'd be about 2.5 years. So we could say about 2.5 years. So in about 30 months or 2.5 years, the account would have $10,000 in it if we're putting in $300 per month at 9% interest. Let's take a look at number 21. Find the monthly payment necessary to pay off a 4-year amortized loan of $5,000 if the annual interest rate is 10%. Well, Let's see, this is problem number 21. So for this problem, we're going to use our amortization formula. So our amortization formula is that P times 1 plus R over M raised to the n power is equal to R times 1 plus R over M raised to the n power minus 1 over R over M. And in this particular case, we're being asked what would be the monthly payment, so we're going to need to be solving for R. Now, we're doing a 4-year amortized loan, and the amount that we are borrowing is $5,000. So P is equal to $5,000. The interest rate we're given is 10%, so R is equal to 10% or 0.1. We're making monthly payments, so M equals 12, and we're doing that for 4 years, so T equals 4 years, which means N equals 12 times 4, so we have a total of 48 payments. And so what we're looking for is what does the monthly payment need to be, and so we can do that using this particular approach. So filling in my formula, $5,000 times 1 plus, again, R is 0.10 divided by 12, and that's raised to the 48th power. Now I wrote 0.10 here, I only wrote 0.1 here, but that's the same thing. And that's going to equal R times, parenthesis, 1 plus 0.10 divided by 12 raised to the 48th power minus 1 all over 0.10 divided by 12. So I'm going to simplify the left, I'm going to simplify the right, and then solve for R. So on the left-hand side, I'm going to just punch this all in at one time. So I'm going to have 5,000 times 1 plus 0.10 divided by 12, close parenthesis, raised to the 48th power. So I'm just punching that all in my calculator at once. Depending on your calculator, you may need to do that in parts. That is going to be $7,446.77 plus, I don't want to round though, so $7,446.77 plus cents, 0493. So again, carry that out. On the right-hand side, I have R times something. And again, I'm going to punch this in my calculator all at once so I can see what that value is. So I'm going to have my numerator, and inside the numerator I have this parenthesis. So parenthesis, parenthesis, 1 plus 0.10 divided by 12, close parenthesis, but just one of them, raised to the 48th power, minus 1, close the second parenthesis. So that's the numerator. And I'm going to divide that by parenthesis 0.10 divided by 12, close parenthesis. And so that is 58.72249,183. So R is times 58.72249,183. And so if I divide both sides by that 58.7249183, R is going to equal the 7,446 blah 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 divided by the 58 point blah blah blah. So if I bring my calculator back in, 7,446.770493 divided by 58.72249,183, that is equal to $126.81. So if we borrow $5,000 for 4 years, and if the interest rate's 10%, then our monthly payment's going to need to be $126.81. And again, technically, if we round down to 81 cents, then we wouldn't actually pay back the full $5,000. So some months we would have to pay $126.82 in order to get that full amount. Let's take a look at number 22. Number 22, we want to complete the first two lines of an amortization schedule for a 20-year, $100,000 mortgage if the annual interest rate is 8%. So if we're going to fill out the first two lines of the amortization schedule, then we're going to need to figure out what the monthly payment is going to have to be. So we were told that we are making a $100,000 mortgage. So we have a $100,000 mortgage. So that is going to be the principal. We know that the interest rate is 8%. So R equals 8%, which is 0.08. We know that we're going to be making monthly payments for 20 years. So M is equal to 12. T equals 20 years, which means N is equal to 12 times 20, which is 240. So we're going to be making 240 different payments. So if I use our formula for amortized loans, that formula is that P times 1 plus R over M raised to the n power is going to equal R times 1 plus R over M raised to the n power minus 1 over R over M. So we have that formula that we're going to be using, and we just need to fill in these values. So again, what I'm doing is figuring out what the monthly payment needs to be so that I can figure out the amortization schedule. So $100,000 times 1 plus 0.08 divided by 12 raised to the 240 power is going to equal R times 1 plus 0.08 divided by 12 raised to the 240 power minus 1 over 0.08 divided by 12. So I'm going to figure out what each side is, so again I can figure out what my monthly payment needs to be. So bringing in my calculator, I'm just going to punch this left side in. 100,000 times parenthesis 1 plus 0.08 divided by 12 close parenthesis, and that gets raised to the 240th power. So that is 492,680.2771. So this is 492,680.2771. That is the value on the left. The value on the right, well, it's R times this stuff in parentheses. So I'm going to do parenthesis for the numerator, parenthesis for here. So we have 1 plus 0.08 divided by 12, close parenthesis, that gets raised to the 240 power, minus 1. Close the numerator parenthesis. Divided by parenthesis 0.08 divided by 12, close the denominator parenthesis. And so that is 589.0204156. So 589.0204156. So R is going to equal this 492,680.2771 divided by the 589.0204156. So if I take 492,680.2771, and if I divide by 589.0204156, that is about $836.44. Again, technically we maybe should round that up, but I'm going to leave it at 44 cents. And so now I want to find the first two lines of the amortization schedule. So for the amortization schedule, I'm going to start by looking at the payment number. And And then we're going to find the payment amount. And then of that payment amount, how much goes towards interest? So interest from this payment. And then we're going to figure out how much goes towards the principal. And then we're going to find the balance. So we're going to start off with a $100,000 balance because that's how much we owed from the beginning. So payment number 0, before we've paid anything, we owe $100,000. So we're going to figure out what happens after payment 1 and what happens after payment 2, and then we'll leave the rest that we could do on a spreadsheet or something. So our payment amount is going to be $836.44. Now of that, a bunch of that's going to go towards interest. Now remember, how do we calculate the interest? I'm going to do that off over here on the side. So that month we owe $100,000. So the interest is going to equal the principal times the rate times the time. So that's going to be the $100,000 times our interest rate, which was 8%, so times 0.08 times time, and at that point it will be 1/12 of a year. So if I take $100,000 times 0.08 times 1/12 of a year, then that is $666.67. So of my $836.44 payment, $666.67 is going to go towards interest. So $836.44 minus the $666.67, $169.77 will go towards the principal, which means after I make that payment, I'm still going to owe $100,000 minus the $169.77. So I'm going to still owe $99,830.23. So my balance after that first payment, $99,830.23. That's my balance at that point. So second payment, I'm going to make an $836.44 payment. So of that, how much is going to be interest? Well, my interest this time is going to be my principal, but my principal at this point is $99,830.23. That gets multiplied by 0.08 and times 1/12. So if I bring that in, $99,830.23 times 0.08 times 1/12, that is equal to $665.53. So $665.53 of this payment goes towards the interest, which means that 836.44 minus 665.53, that means $170.91 goes towards the principal. So at that point, I'm still going to owe $99,830.23 minus the $170.91. So I'm going to still owe $99,659.32 at that point. $99,659.32 is the amount that I still owe at that point. So there are the first two lines of the amortization schedule. Let's take a look at number 23. Jessie has won a $1 million state lottery. She can take her prize as either 20 yearly payments of $50,000 or a lump sum of $500,000. Which is the better option? Assume an interest rate of 8%. So how can we go about figuring out which is the better option? Well, one thing that we can do is we can figure out what is the present value of the $50,000 yearly payments. So that's like an annuity. If we're getting $50,000 per year for 20 years, what would the value of that be presently? If that's greater than $500,000, then that's the better option. If that's less than $500,000, then the $500,000 lump sum is the better option. So this is number 23. So to find that present value, we're going to use our amortization formula. So we know that P times 1 plus R over M raised to the n power equals R times 1 plus R over M raised to the n power minus 1 over R over M. So we're going to find our present value P for this to see how this compares to $500,000. If our present value is higher than $500,000, then the $50,000 payment is the better deal. If the $500,000 is the higher amount, then that lump sum is the better deal. So we're going to find that to make this determination. So what do we know? We know that we're getting an annual payment of $50,000, and that's happening for 20 years. So T equals 20 years. Now we're only getting one payment a year, so that means M equals 1. And since N equals M times T, that's 1 times 20, that's going to equal 20. And we're told to assume an 8% interest rate that we could achieve, so R is 0.08. And so what we need to do is figure out the present value, so we're going to substitute this in and solve for P. So P times 1 plus 0.08 divided by 1 raised to the 20th power is going to equal R, which is $50,000, times 1 plus our interest rate, 0.08 divided by 1, and that gets raised to the 20th power, because that's what N is, minus 1 over 0.08 divided by 1. Now if I clean this up just a little bit, 0.08 divided by 1 is just 0.08, and if I add 1 to that, that's 1.08. So I'm going to have P times 1.08 to the 20th power is equal to 50,000 times the same kind of deal here. 0.08 divided by 1 is just 0.08, and so I have 1 plus that, which is 1.08 to the 20th power minus 1 over 0.08 divided by 1 is 0.08. So I'm going to figure out what this is. So if I bring in my calculator, 1.08 raised to the 20th power here on the left side is 4.6609571144. So I have P times 4.6609571144, and that's going to equal, and I'm going to just punch this all in the calculator at once. So I'm going to have 50,000 times, parenthesis for the numerator, 1.08 raised to the 20th power minus 1, close the numerator, divided by 0.08, the denominator. And so that is 2,288,098.215. So 2,288,098.215. Again, I don't want to round that because I don't want rounding to cause a problem. So the present value is going to equal this 2,288,000 blah 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 divided by this 4.66 and so on. So I'm going to take that $2,288,098.215 and I'm going to divide that by 4.660957144, and that equals 490,907.37 approximately. So now I'm going to round. So 490,907.37. So the present value of this annuity of getting $50,000 a year for 20 years, the present value is only $490,907.37. That is less than the lump sum of $500,000. So that means the lump sum is better. Let's look at our last problem, number 24. So number 24, assume that you take out a 10-year loan for your business for $235,000 at an annual interest rate of 12%, and after 6 years decide to refinance the unpaid balance of $127,960 at a rate of 8%. Use the table below to find the difference in your monthly payments. How much will you save by refinancing? So, number 24, again, we have a 10-year loan for $235,000. So our original loan is $235,000, and that was at an interest rate of 12%, so that's at 12%. And then after 6 years, we refinance. So our new loan, if we completed our amortization schedule and so on, after 6 years, we still owe $127,960, and at that point, we're going to refinance, and our refinance is for 8%. So we're going to refinance at 8%, and so that's after 6 years. This was for 10 years, so this was a 10-year loan, and this is for the remaining 4 years. And so again, our question is, what is the difference in the monthly payment, and how much are we going to save by refinancing? And so again, we're given a table to help us do this in this particular case. So the first thing we're going to need to do is we're going to have to figure out what's our original payment, and then we're going to have to figure out what's our new payment, and then we can use that to figure out the difference and to figure out how much we're saving. So if we had $235,000, again, it was a 12% interest for 10 years. So it's 12% interest. I'm going to use this row of my table and 10-year loan. So for each $1,000, we're paying $14.35 per month. So our original payment is going to be the $14.35 for each 1,000, and we had 235,000. So if I take 14.35 times 235, that payment is $3,372.25 per month. So we're making a $3,372.25 payment each month under the original payment. Now for our new payment, we're at an 8% loan, so I'm going to use that, and we have 4 years remaining, so that's going to be $24.41 per $1,000. So $24.41 per $1,000, but at this point, we don't have as many thousands. We have $127.96 thousand. So 127.96, I'm going to multiply that by. So 2441 times 127.96, so that is $3,123.50. So $3,123.50 is going to be our new payment. So, again, our question was, use the table below to find the difference in your monthly payment, and then how much will you save by refinancing? So the difference is going to equal the $3,372.25 minus the $3,123.50. So I bring back in my calculator here, 3372.25 minus 3123.50. So we're going to save $248.75 a month. So $248.75, we have that much of a lower payment. So $248.75 lower payment. And we're going to save that each month for the next 4 years. So the savings on interest is going to equal that $248.75 a month for 4 years. So that's going to be 48 payments. 4 years times 12 months in a year. So if I take that times 48, that is $11,940 that's being saved. So by refinancing, we're saving $11,940 in interest over the next 4 years. Again, that's occurring by saving $248.75 each payment for the next 4 years. So that concludes our review. I hope this helps, and you should now be ready to take test 3.